On Friday, we talked about converting equations that are in factored form into standard form. And today we're going to go the other way. We're going to learn how to go from an equation in standard form to factored form. And that'll do a lot to help us graph different equations quickly. So just as a little bit of a review from what we did the other day, if I had the equation y equals x plus 3 and then x plus 5, we learned two different ways to expand this equation. The other day we learned the area model. So we learned about the area model, and then we learned a different way to expand called FOIL that kind of works the same way. So with the area model and this particular equation, we would, let's say, the length of a box represent the factor x plus 3, and the width of the box could be the factor x plus 5. And then from there, we're just doing some multiplying and manipulating to fill the box. So x times x is x squared, x times 3 is 3x, 5 times x is 5x, and 5 times 3 is 15. And so from here, we would rewrite this as x squared plus 5x plus 3x plus 15. And we noticed from the other day that usually those middle two terms we can gather together as like terms. 5x's plus 3x's would be 8x's, and then our constant at the end plus 15. So that was one way we were expanding last week, and that's good, and you can use that way to expand from factored to standard form. But then we got a little bit more sophisticated. We're using FOIL. FOIL is just a device to help us remember the order to multiply in. So the F stands for first, so we multiply the first two terms together, and we get x squared. Then we would multiply the outside terms together, so x plus 5 is 5x. I stands for the inside terms, so we have 3 times x, which is 3x. And then L stands for the last two terms. 3 times 5 is 15. And then again, we notice that those middle two terms are like terms, which we can gather together. And I'm left with x squared plus 8x plus 15. The same thing I ended up with when I used the area model. And if I was to go to Desmos and graph these two equations, both the factored equation and the standard form, we would see they produce the same graphs, which means these two equations represent the same thing. So again, if I was to FOIL this expression, not going to use the area model, I want to be a little sophisticated, I'm going to FOIL this. Again, it's the first two terms, the outside terms multiplied together, the inside terms, negative 2 times x, and then the last two terms, negative 2 times positive 7 would be negative 14. And my middle two terms are my like terms that I can gather together. 7x minus 2 is positive 5x minus 14. So next example is y equals x minus 6 times x minus 1. Again, we're using FOIL to expand. I draw the arrows in just to show you what I'm doing, but we don't always need to do that. The first two terms multiplied together, x squared. Outside terms, x times negative 1 is negative x. Inside terms, negative 6 times x is negative 6x. And then my last two terms, negative 6 times negative 1, is positive 6. My terms in the middle are like terms, so gather them together. Negative x times negative 6, negative 7x plus 6. Y equals x times x plus 8. So this one looks a little different. That first term x doesn't have really a factor there. If I need to, I could reimagine that first term as x plus 0. So really this is a factor that has an x-intercept of 0, or an x-intercept that is the origin. So I could think of it like that, or I could think about it like we did in grade 9. I could just distribute that x into the brackets, and I get a term of x squared plus 8x. So when I'm going from factored form, and our generic factored form is x minus r times x minus s, and I'm changing this into standard form, which is ax squared plus bx plus c, James is saying that if you take the r value, whatever that number is, and you add it to the s value, whatever that s value is, it always has to be the coefficient of the middle term. That's one point. Another point James is making is that if you took the r value, whatever it is, and you multiply it by the s value, whatever that is, it has to become the c value. And so what we're going to do on the next few examples is use this information, this kind of rule, to determine how we can go backwards from something in standard form into factored form. That's just an expression that means convert to factored form. So in these next few questions, we're going to be asked to take something in standard form and convert it into factored form. So I think that first example, if you're looking at the pages I provided, y equals x squared plus 9x plus 20. So in this question, if we think about this little rule that we've maybe discovered as we were expanding from factored form to standard form, I'm looking really for two numbers, an r and an s, that I can multiply together to make c and add together to make b. So I want to add to 9, and I want to be able to multiply to 20. So I need two numbers that add to 9 and multiply to 20. Some of you might think you know those numbers already, and I just want you to hold on to that because I want to show you how you can do this if you're struggling with wondering what those numbers might be. So when I have questions like this, I approach it with the multiplication piece. So what are some numbers that I know multiply to 20? I know that I could do 1 times 20. And if I add those together, I get 21. I know that I could do 2 times 10. If I add those two numbers together, I get 12. 3 doesn't divide nicely into 20, but 4 times 5 is equal to 20. And if I add 4 and 5 together, I get 9. So it looks like 4 and 5 are my two values for r and s. And so if I'm using 4 and 5 as my two values for r and s, well, now I can rewrite this equation A as x plus 4 times x plus 5. So I've just taken those two numbers I found and I've broken it out into its two factors of x plus 4 and x plus 5. And I found those numbers by thinking about what two numbers add to 9 and multiply to 20. I listed some factors of 20, adding them together as I go, tracking kind of my progress. And up here, we should, of course, check this to see if this works. I can check this by foiling. X times x is x squared, plus 5x, plus 4x, plus 20. Gathering my like terms, 5x plus 4x is 9x. And look at that. I've got the same equation that I started with. So to talk through that again, we noticed as we expanded this equation, we ended up with a situation where the middle two numbers, our factored numbers, r and s, added together always equaled the b value. And r times s, whatever those numbers are, always equaled the c value. So going backwards, when I have a standard form equation, I'm looking for two numbers that add to 9 and multiply to 20. And so we might have known those numbers right off the bat, but I did some work with some of the factors of 20. I know that 1 times 20 has to equal 20. 1 plus 20 is 21. That doesn't work. 2 times 10 has to equal 20. 2 plus 10 is 12. That doesn't work. And then 4 times 5 has to be 20. 4 plus 5 is 9. That works. And so I took these numbers 4 and 5, threw them into the factored form equation in their different factors, and I checked by multiplying and foiling everything out. And I want to factor this, which means I want to convert it into something that broken out like that, x plus or minus something, x plus or minus something. And so to do that, I'm going to look at negative 28. I need two numbers that multiply to negative 28. So I think about the two factors 1 and 28. 1 times 28 is positive 28, not negative 28. So how do I fix that?
Make one of the numbers negative.
Okay, which one do you want to make negative?
1.
1, okay. So I got negative 1 times 28. So that equals negative 28. This also needs to add to negative 3. Negative 1 plus 28 is positive 27. So I know that doesn't work. I don't know whose voice that was, but we arbitrarily picked to make 1 negative. We could do this the other way, and I could make 28 negative. 1 take away 28 is negative 27. Still not the right answer, but as I build this up, I'm going to use 2 and 14. 2 times 14 is positive 28, so I'm going to kind of do the same thing. I'm going to make one of these negative. Negative 2 plus 14 is 12. 2 take away 14 is negative 12. Still not quite right. I don't think 3 goes into 28 evenly. So negative 4 plus 7 is positive 3. 4 plus negative 7 is negative 3. Well, there's my solution right there. So I found my two numbers that multiply together to make negative 28 and add together to make negative 3. So let's finish off this factoring. I'm making two factors using these values as my r and s value. So I have x plus 4 as my first factor and x minus 7 as my second factor. And then remember, these are important because they tell us our x-intercepts. I have an x-intercept at 7 and 0. and another x-intercept at negative 4 and 0. X squared minus 8x plus 15. And again, I want to factor this. So I start thinking about numbers that multiply to 15. So 1 and 15. When I add 1 and 15 together, I get 16. And I'm looking for two numbers that add together to give me negative 8. So how am I going to hack this so that when I'm multiplying these two numbers together, I get a positive number, but when I add them together, I get something negative? What do I need to do here?
They both need to be negative.
They both need to be negative, yes. So I'm going to make both of these numbers negative. Negative 1 times negative 15 is still positive 15, but when I add these numbers together, I get a negative value, negative 16. Not quite my answer. 15 and 2 doesn't go into 15 nice and evenly, but 3 and 5 works. If I make these both negative, negative 3 plus negative 5 is negative 8. So those become the numbers in my factored equation. And so factoring x squared minus 8x plus 15 into factored form gives me the two factors of x minus 3 and x minus 5. Okay, I'm just going to keep going through these examples. The method is always the same. Two numbers that multiply to negative 9 and add to negative 8. So I could do negative 1 and positive 9, that adds to positive 8. Or I could do negative 1 and negative 9, that adds to negative 8. That didn't take me too long. I get x plus 1 and x minus 9 as my factored form. Question E, y equals x squared plus 3x minus 18. So see if you can think about two numbers that multiply to negative 18 and add to 3. Two numbers that multiply to negative 18 and add to positive 3.
3, negative 6.
3 and negative 6. So 3 times negative 6 is negative 18. I think 3 plus negative 6 is negative 3, not positive 3. So let's switch this around. Negative 3 times positive 6 is negative 18. Negative 3 plus 6 is positive 3. Well, that lets us factor this. X minus 3 is our first factor, and x plus 6 is our second factor. It doesn't matter what order you write those factors in either. As long as you're consistent with the signs, you're good. Y equals x squared plus 3x minus 5. So again, I'm looking for two numbers that add to 3 and multiply to negative 5. And I think I've only got two possibilities. I've either got negative 1 and 5 or positive 1 and negative 5 for two integers that multiply to negative 5. And neither of these add to positive 3. So what do you think this means when I can't find integers that I can multiply together to create negative 5 and a positive 3?
Could be a fraction or a decimal.
Okay, how long? Go ahead. I think that was Vikram.
Yes, I think it could be possibly 6 too. So like instead of 3x, it must have been 6x, but it must have gone simplified down.
So that still doesn't solve my problem. I'm looking for two numbers that multiply to -5.
Yeah, and they'd equal 6.
But I need them to equal 3.
All right.
Right? I can't just arbitrarily change the equation to make it 6. Because then all of a sudden I would have changed my graph. So I did hear somebody say maybe it's a fraction or maybe it's a decimal. How long might it take us to look for a fraction or a decimal?
Depends on the decimal.
Okay, can you think of any fractions or decimals that multiply to -5 and then add to 3? I can't think of any off the top of my head. And the whole point of factoring the way we have been factoring today is to make things simple and easy and do things quickly. And if I have to spend a whole bunch of time thinking about fractions and decimals, I might as well do this another way. Can anybody right now go to Desmos and just throw this equation into Desmos and tell me the x-intercepts? So go to Desmos, type in x squared plus 3x minus 5, and I just want to hear what the x-intercepts are.
The x-intercepts are -4.193
Okay.
and 1.193.
Okay, so just in all seriousness, if we were trying to do this by like guessing and checking almost, how long would it take us to find these decimals? If we
Quite a while.
If we didn't have the graph, it would take us a while. And so we're never going to try and factor something that has decimals that awkward. So when we have a situation where our equation doesn't resolve itself into some factors that have nice integer numbers, we're just going to stop. And I'm going to say that equation F does not factor. There's no nice factored form that we can come to very quickly that would represent this using the methods that we know for factoring. So that's where we're going to stop.